who asked them aren't around anymore because I don't see anything new in the Twitch chat, but I'm plugged in now, so the computer should last pretty much indefinitely. So hopefully I won't miss anything else. So let's get back to this. Alright, we're going to need a members macro here. And the idea of the member macro is we just go like this. Right? Grab a pointer to 0 of the type of S, and then dereference that to get M. That lets us reference the member of a struct. And then we can get things, all kinds of things from that. But what we're going to get for right now is we're going to get offset of member, which we have to get by doing the address of the member and turn that into a pointer. Pointer as int a is just pointer diff a minus 0, which is a b a minus b and then we can get the thing we're actually after, which is not offset of member. I lied. It's cast from member. So we're casting like this. What we want to do is we take the pointer diff, no, sorry. We're taking that, and then we're taking putter as a byte pointer, and we're subtracting the offset of that member. Right? So we can ask, what's the offset of that member? And we can subtract it from this pointer by a number of bytes, and then cast it to the thing. And in this way, if I say, here, I have a pointer to this thing, and I'm telling you that it's a member of this greater struct, cast from this member to this struct, and then it will do the pointer correction to the containing struct. And the way that works is we just go, look, marker list node contains a member called list. I want you to cast it from this pointer called list. And that gives us a marker list node, and then we can delete that. Gym Zero, the 4coder doesn't try to communicate with itself like that. Yeah, I would guess that the reason that's happening is that it's sort of a CPU load thing. Memory load thing. I don't know. I'd have to investigate a little bit. It's a little surprising. Thanks for asking. I'm not sure. Am I missing something here? Zero. S. You don't like that? No, that's fine. That's okay. 1, 2, 3, 4. Oh my gosh. Stop it. That's weird. That's supposed to be allowed. Isn't it? I don't know. Okay. So we got all the stuff on that side fixed. Now the problem is that it doesn't like this. So we need to go and find out more about this guy here. Here's the implementation. User data. User data size. How are we typing that? User data size. Okay. Rounded user data size. And how do we get that? Well, we'll get that by taking the user data size and L rounding it up to a multiple of 8. I have a little bit of a back cramp today. Okay, so Yeah, so what we want to do is we want to figure out where the marker array is hanging out. There it is. So right now the marker array knows about a linked list of other marker arrays for the allocation scheme. It knows about, I hate these commas, commas. It knows about its buffer. It knows the count, the sim max, and the max. I'm not here today to question what any of that means. I'm just here to say there's also the user data size and the user data rounded size. Okay. Then what we're going to do is we're going to say that the array, yeah, we have to be careful now because all the code that deals with these things is wrong. Marker array. I want to see all occurrences of that. Here, I am initializing a sentinel. Here I remove all the markers off of a file. Here I'm allocating the memory I need. Memory size minus that, minus the rounded user data, divided by the size of a marker. General memory allocate. We grab that, we insert it, and then we fill with all this information. I think this is the right place to memcopy into array plus 1 the user data buffer ID. That doesn't change at all. We are going to want to do something like data get user data from marker handle, void handle, markers, data dot data equals markers plus 1, data dot size equals markers dot user data size, return data. Oh shit. Okay. You don't have a thing called data anywhere, do we? Get out. Yep, okay. Okay, so that gives me the data right there. Now, if we could please continue doing this. Allocate it. Get that. Markers set. So here's where I grab the markers, I check that this matches this, and then I go, alright, now I'm going to try doing this in a different way. So if the handle does not equal 0, return false. Handle does equal 0. If this does not equal this, if first index plus count is greater than simmax, return false. The new count equals first index plus count. There it is. There's some macro called marker array base. That doesn't work. Boom. Boom. There we go. Don't wrap it like that. So the way this works is we start at A. We add the size of a marker array structure, and then we're also going to add, take a marker array, pointer from A, and add the rounded user data size. There we go. So that should fix everything, hopefully. I guess we should keep going through the marker arrays just because who knows, right? So new count equals that. We expand it. So we take the destination plus the first index from the source, and we grab that much memory. Okay, markers get. Here we are doing all that weirdness again. Let's just change all this. So if the handle does equal 0, return false. If this does not equal that, return false. this is greater than that, return false. And then finally, memcopy outward from the source, from the first index, the amount. Got it. Okay. Markers free. Again, I'm going to try clearing out all this weird stuff. So if the handle does equal 0, return false. If this does not equal that, return false. Otherwise, we remove the markers from its doubly linked list. We marker count. Subtract that, and then we free those. Okay, that seems reasonable. Here we're iterating the marker array to fill the cursor array up for the cursor fixing. So there we go. That's all of it. Alright, I think the internal user data stuff mostly works. We do need to expose it to the API. Add markers. You can go away now. API export. Defines data types. I'm just going to throw this down here. Struct data. Is that the way I do it? No, I think it's like this. Struct data. Doc. This is all binding stuff still. I want to go above the binding shit. Oh shit. Alright, API export, return data please. Get user data by marker handle. Application links app. Marker handle marker. Buffer no. Data equals get data from get user data from marker handle marker data return data. Return that. Right, uint 8t, uint 64t. Return true. Ooh, man. back is cramped in a sort of annoying spot that I keep like tweaking when I'm moving my hand around from typing to like drinking water. Okay. Okay, so that's not the end of the road yet, because now what we need to do is go back to the sticky code and finish it. So we now stuff this stuff into those. Let me actually run this in the debugger first. Make sure I didn't break anything that was already not broken. Well, that's weird, isn't it? When I make a change here, it should appear as an exclamation point. That's a bug we're going to want to look into, because that's going to be kind of annoying. So, good, but here's the real test. We still crash when we do. Why is compilation showing a star? Something is totally fucked with the status flag thing. If I close this, and then I go boom, and I close it and go boom, there we go. Okay, so now what we want to do is we want to say, when we end a file, not only do we check to see if it has a list and we delete that list, we can also do it the other way around. We can say we want to check all of the attached handles. Oh shit. Does this actually help at all? So I was saying that this would be helpful because now we have a back reference, right, from here to here. But just because this system is in play doesn't mean all attachments to this thing are of this type. Maybe some other system has attached some of these as well that work differently. And so suppose there's like 3 more on this particular one that are for something else. And so we'll say, let's imagine some other nebulous magical system that has added these things. When we go to delete this file, or this buffer, right, when we're closing it, we're not gonna be able to tell which markers came from which systems unless we ask those systems, hey, did you make this? And then it can check, but that'll still just incur an iteration across the internal structure of that system, which was the whole thing we were trying to avoid. It can't just go read each of these things and see if it's of the system we want, because it doesn't know, like, this system could have used the exact same data format as this. They might both be stuffing a single pointer, and then it looks the same to both of them. So they could unstuff those pointers and then go, hey, does this pointer mean something to you? Yes, no, but that's the same as just saying, does this marker mean something to you? Yes, no. So it seems like this actually doesn't work. Stuffing the user data in there isn't enough. We need to stuff a callback into it as well. And the reason we need to support that from the internal side is I have to support it so that two people like this and this, who are two separate systems, are forced to agree on that basic structure. You stuff a callback and then whatever other data you want, basically a closure, onto that thing that tells it what to do upon its destruction for cleaning itself up in the other system. And this is why I don't like having these things get attached into these buffers, but I can't think of a different way to set them up. Okay, so here's some thoughts. Maybe we just want to be able to attach to any buffer closures that are like, call this closure on destruction or something, right? And it's per buffer because when we're creating a closure, the data we pass on to each one might be different. Certain buffers might not participate in that particular system that wants that closure, so that wouldn't even get pushed on there in any form. And this would allow us to say, hey, I've attached something to you that needs to be dealt with when you get deleted, so call this thing to deal with that, and also give me a handle to it so that I can remove it from you if I change my mind. That is going down a direction that I am deeply unhappy with. Because basically what we're talking about is, in addition to having all these, we're going to have this system attached a little callback thing that's a separate attachment to the buffer. I'll represent that as this circle thing. So now, where am I going to put it? Right here. So now upon destruction, there's this callback that has a closure for this thing and this thing, or maybe it just has the callback for, I don't even know. It would have this and this, I guess. And then it would be able to go call this thing, and it has some procedure over here, so it's some runtime executable instructions, which I guess we would represent with something right, it's got some executable code to call. So then it calls that and passes these references into it so that that can clean up this thing, and then this system down here maybe has a separate attached callback right here that is also getting called. Right, and these systems are manually adding and removing these and keeping handles to the callbacks they've attached so that they can manually add them and remove them, and stuffing those callbacks with opaque data that gets operated on like a closure. Right, it's not great. How did we get into this situation? Well, we're here because this system is adding is under user control, and it wants to add behavior to buffers that tells them what to do when they get cleaned up. And we might have, not only do we, so we basically have, yeah, okay. Here's why these things get tricky. Let me start a new canvas. Give me black. Can I get like a smaller brush, by the way? Okay, so here's what basically is going on. We've got like a set of buffers that we're using, right? And this is just some data. This is just like data in a data structure. We'll say there are n of those buffers. Okay. Now we have code that controls that, and the data structure, the code that describes that data structure and all that, is on the inside of the core system. Core. Now over here we have the custom. I will abbreviate it to cust. The custom layer, and it has multiple systems, right, that may want to interact with buffers in different ways. So suppose we have here one system is our sticky jump system. And this has to be a system, it's not just some code, because it generates data that gets stuck onto these things. So we'll call this sticky. Right? Here's our sticky system. Sticky jump system. And basically what it's going to do is it's going to create a couple of sticky lists, probably. We usually have one for an error list, maybe one for a search list, and maybe one for what else do we use? We have like the declaration list. So we have a couple of these sticky jump lists that it controls directly. It's got them in a linked list to each other. And these get attached to specific buffers. So if I say alright, there's like a loose connection to this guy, and this guy, and these are search buffers that contain these things here, right? Now, each of these is a list, and so those lists are lists of the attached jump points into other buffers. So while this system does loose attachments of this data to these buffers here, it also goes and asks, hey, I need a specific type of attached data called this handle, like these markers, and so we end up with markers attached here like this, and those are inside the core, and then each list contains its pointers to those. So this guy has a pointer to here and here maybe, and then maybe this one has 2, and this guy has a pointer to this one, and this guy has a pointer to this one, say, right? So these are handles that reference things back in there. And then what happens is all of these things we've built up, this system wants to say what happens to clean these things up when one of these buffers gets destroyed. At any time, an operation that can happen is that a buffer ends, and all of its previous affiliations are supposed to be cleared. And when this happens, this system here wants to specify what happens to these guys when they clear, and what happens to these guys when they clear, right? And those aren't the same thing at all. It's also possible that there's one that's in both camps, and so we have a fairly just arbitrarily complicated thing. And not only do we have this one system that does this, but we want to be able to say that the custom layer can implement an arbitrary number of systems that can build their own data structures, do Turing-complete work. So we'll call this like system 2. I'm not sure what an example of another system might be right off the top of my head. You know, one good example would be the iterative search thing for like for when you're doing this stuff. That is basically a system. You know, there could be others quite easily. And so when you create these different systems, right now there are no data structure that describes these systems at all. There's no data that can be sort of examined. It's all just Turing complete code. We just write code that is this system, we write code that is this system, we write code that is this system. And then That code is responsible for being able to call the API in all the ways it needs to create loose connections. For that, it's just usually making a hash table and using buffer IDs for its data structure. For attaching specialized things that are not just some arbitrary loose attachment, because they have to be incorporated into how the buffer updates when it gets edited. And then those systems have a few operations that they support. So while the system is running, we can do certain operations like jump to buffer, or jump to, like, execute a jump, right? And then we need to be able to answer the question, what happens when a buffer gets deleted, given that it's got extra data associated to it from this system. And so what I think we are seeing is we need a little bit of like a data structure that lets us say, declare that there is some kind of system here, and the code that operates, is basically described with a little bit of data that we store right here that models internally what that system is like inside the core. Right? You guys follow that? So the idea is the core needs some data to help it model these systems a little bit. It doesn't need to fully understand what the system is going to do, because that would involve fully understanding Turing-complete data, which isn't going to happen. But we just need a specific enough model on the core side of what systems exist that it allows those systems to easily express themselves, while not forcing the core to know so much that we're solving unsolvable problems, right? And so kind of what I'm thinking here is maybe we want to do something like which one is it? Space. Maybe we want to do something like this. Maybe the core side has this list of buffers, right? Buffer, 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 dot, dot, dot. And then maybe it has a list of like systems. I don't know what shape we want to use, but I'll just use a little oval if I can. And so it knows, like, alright, maybe the custom code declared that it has 3 quote-unquote systems running. I need a better name. And a system will have basically attached to it an ID that was generated at runtime. So when the user called it, it said, give me a new system, and it got back a reference to its system ID. And then what can happen is a buffer has attached to it some data. It can be told this data is associated to this system. This data is associated to this system, right? This data here is associated to this system, and so on. Now, the sort of nebulous cloud of code that implements these things on the core side, or on the custom side, can still be a nebulous cloud of code, and they just at init time create and then store these things here, which are references, which allows the core side to create a kind of concept of, alright, we have another thing that wants to manipulate data in a specific special way, that it data that it attaches to buffers in a special way, and here's the reference to that data description, and then it can add things onto that descriptor that are basically like, here is the thing I want you to do on a buffer when you destroy it, with what I want you to do with this attachment data. Now, this is kind of a can of worms. I mean, we're still ultimately getting to the point where what's going to happen is we're going to attach to this a callback that we can use for deleting these things, and then these attachments here know which system they come from, which is how they find their cleanup callback. They also know they have some like user data that was stuffed into them by this code down here, so that when they call this, we're calling back into some shit in here, right? And you see how this is just becoming complicated, because at the beginning this creates this thing, and then it can create this thing, right? Which is how it gives it this pointer back to this thing, and then upon destruction this thing uses this thing to find this thing to call this thing. So yeah, so there's some other possibilities. Unfortunately, Jim, what you're suggesting doesn't quite work. So Jim is proposing this. What if instead of having core data, he's suggesting that all attachments look like this? We have a buffer, 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 dot dot dot. And you're basically suggesting all attachments look like the loose kind, like this. Whatever it is, here it is, here it is, here it is, here it is, right? And then these can just be code that own and control these things directly, which is the very clean way that you'd expect me to write this, that I would expect to write it, that makes perfect sense. Except that there's a problem, which is that there are operations that can be performed without the knowledge of any of these systems. So here are systems that want to implement these things, and then let's suppose there are some things that aren't really complicated systems, but they're just like, okay, a buffer gets edited, there's a command that lives kind of on its own as a little executable thing, a buffer gets deleted, or closed, I'll say. Right? Boo, 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 boo. So now what can happen is we can say I close this buffer, right? And a user can do that at any time. And what happens is this system here is now going, okay, I have this data here that's associated with this. I needed to know that this thing got closed. How am I going to participate in this operation? Because before the system was in there, yes, closing was simple. I'm trying to customize this a little bit, and now when I participate, when I'm a part of the system, when I exist, closing has more meaning. Closing has to do more stuff, because closing has to check and see if some of this kind of data exists and do something with it. Maybe just free it, but maybe something more complicated, which is the situation we got into, right? So what we have is, you know, and then these things can actually have operations too that are like, all right, here's some operation I want to be able to do, foo, and that operation can get arbitrarily intermixed with other things that, you know, so the person who wrote these things was Alan. He wrote these default stuff, and he wrote this sticky jump thing over here that, you know, does stuff. So this is like Alan wrote this, and Alan wrote this, and he shipped it to everyone else. Now Alan didn't maintain, say, some Git source control integration, and so I don't know. Let's say Jim wrote this, right? And let's say neither of us wrote this other thing, but you're using something that was super useful that you didn't want to rewrite, and it's a lot of work. And so we'll say, I don't know, who's someone else who does a lot of stuff? We'll say Dave / Croifa wrote this, right? Now, here's where things get complicated. We want to make all of this code work simultaneously. You can't really avoid, you could say I'm not going to use other people's customizations, but you can't avoid the fact that you have to use a lot of my customizations unless you're just going to rewrite everything. And so what are you going to do? Track down all the places where an edit happens, because here's why you would need to do that. When an edit happens, suppose someone uses this edit operation, and it changes this buffer here, well, that could mean that we need to change this buffer here, or this data here. And so if the core doesn't know that, then who's going to make that change, right? Edit can't possibly know about all of these things. Edit could know about this one and have a special case for it, but what if your cool thing also influences how edit works, so that if I edit this buffer here, then somehow, or if you edit this buffer here, right, then that change needs to get propagated into this data, and that change needs to be controlled by this code that you wrote. Well, how are you going to get that opportunity to make this change? Well, we could put just, the idea that it's like, okay, whenever an edit happens, you get a hook that you can insert yourself into, but now we have this sort of nasty situation where these two also want to be participating in that hook. And so we can't just have one single hook, right? We would end up having to make a chain of hooks, and then you get into a nasty situation where you haven't really controlled the rule by which every particular hook has to come in a particular order. Is it the case that with this, maybe when you edit this way, this particular system here actually changes the meaning of the edit somehow, like it applies more edits or it reverses them or something, and it needs to happen before this thing, which will do something about after the edit, updating the history or something, right? The order of these applications can matter, and so simply putting a hook in won't be good enough. Furthermore, if we go the hook route, then what happens if this, which I put in before, because I was hoping to get here sooner, but I didn't get here soon enough, what happens if this here is an operation that this should know about, or that this should know about for some reason? Well, one reason that these might need to know about that is if this operation does one of these things, and then it would just be like, okay, well, as long as these hooks are set up, it'll come through the way we need to. But it's not clear that there won't become a situation where, I don't know, you create a system that it becomes pretty useful, and then this thing needs a hook really because it's got a meaning all of its own, that other people make a system that relies on this system, right? And this is kind of a dependency argument, I guess. But if this depends on this, it wants to know when this is happening, and it feels like it'd be nice to just in general have a bit of a story about how these kinds of things are actually going to happen. But if it's done this way, which I'm not saying is impossible, but it somehow has to be done in a way where anytime an edit happens for any reason, including generated inside the core, right? Because even the core can do operations that are basically edits. Which is why the core controlled this data in the initial version of the sticky system, of the marker system, and I'm pretty sure the marker system is correct, because the core can generate edits that don't go through the custom layers code at all. And when that happens, what are we going to do? Are we going to have some kind of hack that figures out what hook to call for everyone else to get their information? I'm not sure. I'm not sure that works very cleanly. The reason I put the data on the inside in the first place was to avoid having to go too far into hook hell, which is where it sounds like this is definitely going to have to go. But that's also where it sounds like this would end up going too. So not helpful, Insobot, not helpful. No, yeah, that won't be good enough, because just seeing that just seeing that an edit did happen isn't good enough when something like what you're trying to do is something like updating all of the positions. Like the idea that we have a bunch of cursors or like markers that are inside a buffer, and that they need to be edited, they need to be moved around when the buffer edits, so that things that are after an edit get shifted and things that are before it don't get shifted. That is something you really want to do. You need the full context of the entire information, what the buffer looked like before and after the edit to do that correctly. And like if we're going to do things like I want to do, like say customizing your own virtual whitespace control, that might become a thing that's complicated enough that you really kind of want to control more data than what 4coder stores internally, but that you update on the fly with the edits, and I just don't see that being something you can do without good data structure based things that avoid all this hook stuff. Like the marker thing solves a lot of those problems, but it creates this situation where instead of having to go through crazy hooks land, we instead have this problem where data gets associated on both sides of the boundary, and then as soon as something needs to happen that's dependent on like keeping data synced across this, we all of a sudden need hooks again. It's not good enough to just get a flag that says a change happened. You really want to be intimately involved, especially with these markers, right? Yeah. So what are we going to do? What can we do? It's not good enough to just stuff the data in the way we are now. Each attachment to a buffer could be controlled on the core side, and the custom side is just saying store this for me, and it can assign special meanings to certain things, like this is data you ignore, this is data that is a bunch of a bunch of markers to update on edits, but then what are we going to do? Iterate all of those. Well, the marker is just a special case of the thing we're trying to deal with. Maybe we need just a general system for being able to say we attach something to a buffer, and within that attachment system, yeah, so all of that's kind of hacky, Jim. You don't want to go down that route where you're, I mean, you're assuming at any given point that there's some kind of control flow that makes sense for when to do these things, right? So an edit happens, first of all, everyone needs to be notified at some point that it happened. If they get that notification, then the systems can look at the they can look at the undo redo history, but that assumes that the undo redo history is like a primitive object in the system that we can count on to be like stable enough to be the basis for this. And in reality, what will probably happen is the undo redo system is something that you want to implement in this system, right? It'll be one of these nebulous blobs of stuff. Yeah. So if we had a generic plus, even with the undo redo system, you'd have to do a lot of work all the time to back solve to the original edit, and you also have timing problems, because if an edit happens, that edit you have to make sure that by the time it matters what the markers values are, that they've already been updated, and that's the direction I don't want to go either. I want them to always be right. It minimizes the amount of CPU work that actually goes into it, and it minimizes the probability of there being timing issues where you need the correct version of this cursor now, but you don't get it until the notification pass happens, and then that means it's not right to the next frame, but the command will already be done executing by then. So, some thoughts. Whoops. Let's do this again. So, for one thing, I don't have any idea right now in 4coder that a buffer might have things attached to it, with the exception of the markers. The markers can be attached, but they're kind of just a special case weird thing sitting there. And it might be the case that we want some kind of general story about what attached data looks like, and then there can be special a part of that general story is that the attached things can have special cases that get blended in with the rest of the engine, or they can just be raw data that sit there. But we want some kind of full system for talking about what those attachments look like, and that applies to all of them. And there's a few things that we know. So we could say that an attachment always belongs to a particular system, and that all those, custom side, edit, and close operations are actually a part of a system, and there is no operations at all that are just floating on their own. That's not a change we can make today quickly, right? But I'm kind of proposing, like, over here we have these, over here we have these, and all operations have to belong to one of these. So, like, we could have the default system that's got, like, insert character, backspace, etc. Yeah, I don't like where that's going already. So maybe what we want to do is when we define a system, we say here are the basic operations of the system, and then other commands can be implemented as things which call to those. So we have like commands which just do what they do, and they're code that you call that calls into these operations if they want to. And these operations have, why do I want that? I actually maybe don't want that. Well, point is, if these have attachments, these have things attached to them, and we just want to be able to say how do we make sure that these get fully they get all of the, the code that wants to control them has full control without things getting out of hand. One thing that would prevent things from getting out of hand is if I don't have to do a lot of adding and removing of callbacks, but I just declare the callbacks once, and the core does all of the controlling of when callbacks do and don't apply by some very predictable rules, right? So, for instance, one thing that was initially concerning about this situation we're in is that if I say that, okay, an array of markers can be attached to these things, and just stuffing data in there isn't enough because two systems might both stuff similar looking data into their own thing. And so now what we also have to do is, along with the data we're stuffing, when we go to delete this, we look at it and go, I don't know what system you're from. And furthermore, if we're trying to make a single hook that deletes these, I don't even know which system. Does this system own the hook? Does this system own the hook? Do we have some kind of like thing here that's like this guy has a hook and this guy has a hook, but here's the hook we use when we're using both of them, and how do we decide which one to hook into the core? Or do we chain them so that this one has a hook and this one has a hook, but they both get chained together over here? And if we do that, how do we know that they're not doing redundant work and stuff like this, right? It goes on and on and on. Maybe we eliminate the idea of end buffer hook, or we keep it but we don't try to solve that problem directly. And instead we say that each of these little bits of data knows which system it came from, and that system acts as kind of a v-table to tell it what to do when it gets deleted, what to do when it gets edited, and you know, anything else. And each of these things has one of these like v-tables. But it's not the idea that we're saying here's some object and we're inheriting from this, but it's more like we say this belongs to this system, and this system contains the code that tells us how to handle these situations, right? This system is forced to declare those if it wants to, right? So it can say here's how I delete if you care. If you don't, then it just doesn't do anything special on delete. And it can declare here's what I do on edit if it wants. I don't actually know if we would need that kind of thing, but maybe we would. What would the code look like for this? Well, every system would have to be initted at some point. Which would be a little bit annoying, but not too bad. And then on that init time, it would declare the behavior of the things it creates to the core, and then its operations, which are just some commands sitting over here, would be like, oh, create something of this, you know, attach some data here, and this is its system. That actually doesn't sound too bad. I feel like I could live with that. Now, while we're going this direction, we would also want to be able to answer the question of, can we make this like a little bit more general, the idea that we just have a variable attached to a buffer that we're not having to store on this side, and that it's easy to query it. And what we could do is we could say each attachment has to have a unique like name/identifier code and a unique system pair, right? So this system might say I'm using indexes 0, 1, 2, and 3 to name my types of data, and this system declares that it's using 0, 1, and 2 to type its data. And these don't conflict because each piece of data gets typed, one by the static number that's chosen by the system, but also secondly by the system itself, which gets us a dynamically chosen number at runtime from the core that it uses to identify itself to the core. Then we could do things like go to a buffer and say, hey, I'm system 0, and I want to know if you have data type 1 attached. And if it does, it returns it. Now that's assuming that we only ever want one, but I guess what we want to also maybe talk about is, do we declare types, or do we declare, like, we might be able to use these numbers as names for variables, right? And then if we want to be able to say, look, there could be up to 30 of these things, we just allocate a range of 30 variables, integers, when we're defining our system. Yeah, the core doesn't really need to know what those names mean or what the types mean at all, I don't think. Would we give it types? I don't think we would. The types would be up to the user to stuff into the data if it wants if they want types. Or to infer from the variable number. Yeah, this solves some interesting stuff that I put off for a long time too. Okay, so that's what I will do eventually, but I don't want to go down this road today, because this is way overkill for our current situation. For our current situation, the equivalent will be to stuff a callback into these things, as that is kind of similar to just saying stuffing the system number and a variable number that allows that system to process it from its vtable down here. Since we only have one element in each vtable right now, instead of doing all this, we can just stuff that directly into there. So there we go. Alright. Yes, we're working on 4coder stuff today, by the way. I know I put that answer off for a while, but there you go, you have my answer now. So here we go. Marker array. We're now going to go to, whoops, types.h. We want to make a callback type. Alright, so yeah, along with that we probably want to pass in the application links and the marker handle in question. Alright, that should be a good start for now. I'll keep thinking about that system thing. That's been on my mind for, I don't know, like a year, 2 years. How do we make APIs where several people all want to contribute, like you want to be able to use other people's customizations and have them just work, but those things that need to just work are basically modifying operations that exist. How do you have more than, like, how do you set that up so that two different people who didn't work together can have their work merged when what they're merging is so complicated? How can you can't make it perfect, because you could easily just contrive situations where two people make things that can't work together, but that's up to you as a user to prevent. The idea, however, in general, is to make it as easy as possible to merge things that should be able to merge conceptually, right? There's no such thing as preventing things which can't merge from existing and compiling, I don't think. right? Alright, so there's our callback type. We're going to put one of those right here, and then we're going to go to the API implementation. So when we add markers, in addition to everything else, we will add a marker delete callback pointer, and that'll go right here. Ah, shit. Alright, so here what we're going to do is static void sticky cleanup application links, marker handle, user data, user data size. We then want to say if the user data size is equal to the size of a pointer to a marker list, then we're going to take a marker list by going dereference marker list pointer pointer user data, marker list remove references list handle. Marker list, marker handle, never did do that renaming, did I? If, let's get sticky jump destination array dest equals list handles plus plus dist, if dist so whenever I say ah shit, it's because I did the build with the panels split, and so it's free for me to do this. It doesn't cost any computation power, but as soon as I run the build, it does cost computation power because it goes and relays out all the buffers according to the new width. And the reason is when you create buffers, it doesn't fix the layout under special buggy circumstances, but I decided not to fix it because it's such a pain in the ass when I'm streaming. I made this decision consciously a few versions back when I realized how slow it had gotten to create and destroy panels, and I noticed the only time it doesn't happen is when I'm in this situation and I do this. So I haven't got any clue why that doesn't trigger a relay out, but it doesn't. It also doesn't if I do this. That doesn't trigger a relay out, although it wouldn't matter because the width hasn't changed in this case. For some reason, normally when you change the width of a panel, it redoes all the layout, but for some reason in that one case, like going from 1 to 2, or maybe it's when you are creating a vertical split, it doesn't do it, but for some reason in those cases it doesn't. And so as long as I don't build with two panels side by side, I don't waste like 3 seconds waiting for everything to relay out. There we go. So that removes all the references of that handle from the list. And so now we can do sticky jump markers cleanup. Okay. Allocate markers state gets defined right here. Oh man. Okay. Oops. Oops. My head. Okay. Got a little, I don't know, lightheaded there after I was dealing with my back cramp. That was weird. So now we're stuffing the callback onto the array structure there. Markers get, markers free. General memory. So when we call markers free, okay, I want to know, so the file, does that just get called in API implementation? Yeah, so that's just buffer remove markers. Right. That's just when we remove the marker that happens. So when do we delete destroy buffer, buffer destroy, buffer close, close buffer. Alright, I'm just gonna look it up. kill buffer. Kill buffer. I call kill buffer. If that's under view.cpp, interactive try kill. Ooh, interactive try kill. There it is. Interactive try kill file. Kill file and update views. Okay. So where's kill file and update views? It's under view. So what is it called? Working set free file. File free. That's the one I'm going to want. File free. Buffer data. Tokens. Still lexing. When were you going to free your attached markers, though? Alright, marker array. Marker array. Clear file markers state. Nope. That's the wrong time to do it. File free. And then what we're going to do is we're going to say if these markers here, or this marker array here, callback does not equal 0, then we're going to call it. And so now we need to figure out where to get the app links. I think we can just do it like this. Here's the marker array itself. Here's the marker array user data, and here's the marker array user data size. Right? Ah, shit! I did it again. Okay. So that's not good enough. What if I just pass it in here and pass the buck to someone else? It's their job to pass it in properly. Then what do you give me? Right. And here, can you get app links? No. Okay, app. Application links. Working set, free file. Hook. Ah, there it is. It's under the models. Okay. App links. How on earth is that the one that I copied? Oh my god. Alright. So, that's Crazy Town, but let's take a peek. Why is this yellow? Dismiss all. Okay, let's see how this goes. Drama clock, code, open all code, build, jump to some errors, looking good. Oh, gonna close that file now, and I'm gonna jump to some errors. Perfect. And now, when I'm jumping to errors, my handle is null. Perfect. That's what I wanted to see. Get buffer ID from marker handle. Yes, you are doing the right thing. No. So here's where I'm going to add in a helper that just says, alright, if someone passes in a 0, we're just going to return them a 0 buffer. That's what I think we'll do. Yep, that's what we'll do. So, that's in API implementation 8.22. So anytime you want to set the data up to just flow through indicating that there's no buffer, you just set your handle back to 0. You know, for all that work we put into it, I'm not even sure that I like that result. I probably would have been happier just destroying all the marker lists. In this case, at least. But hey, it's there now. Alright, up here. Callback. There we go. Jump, 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 close the thing, and no crashy crash. What do you know? We did it. We did it. That was a pain in the ass. Alright, so we're making good progress. I mean, that one was just ridiculous, but these won't be quite as bad moving forward. I think now is a perfectly good time to pinch it off, take a little break. We're approaching an hour and a half, or we're just past an hour and a half, which is about is a good length for a video. So I'm going to take another little break here, fill up on water, you know, rest my back and my eyes, and we'll keep this going in about 5 or 10 minutes. See you guys in a bit.